Hello everyone, my name is Euros Vasiliou, and this is my final project for Big Data Management and Processing course titled Netflix Big Data Analysis. For this project, I used a dataset from Kaggle containing a little over 8,800 Netflix movies and TV shows from 1925 to 2021. It includes fields such as the type, release year, genres, countries, duration, and the day the title was added to the platform. My goal was to study catalog growth, content distribution, and patterns across countries and genres. This dataset clearly connects to three big data dimensions: variety, veracity, and velocity. Variety because the data comes in multiple structures and formats. Some fields include multiple countries or gens inside one cell. Duration mixes minutes and seasons, and there is a mix of text and numeric values. This makes the structure non-uniform and requires reshaping. Veracity because the raw data contains missing values, inconsistent formatting, and duplicates, so the data cannot be trusted immediately. It must be cleaned and standardized before analysis. And velocity because the dataset captures how the Netflix catalog evolves over time by analyzing when titles are added. The project measures the rate at which the platform expands and updates its content, especially after 2017. To manage and process this data, I built a simple end-to-end pipeline. First, I loaded the dataset in Python using pandas. Then, I cleaned and transformed it to solve variety and veracity issues by removing duplicates, filling missing values, extracting the year from the dataset, splitting countries and gens into lists, and separating duration into a number and a unit. After cleaning the data, I stored it in MongoDB using a document-based NoSQL model. As you can see here, each document represents a single Netflix title, with fields such as the title, type, release year, the year it was added to Netflix, its gens, the countries where it was produced, and its duration. I converted the gens and countries into arrays so each title can naturally store multiple values. This structure handles variety much better than a relational model and avoids complex joins. I also created indexes to improve query performance as the dataset grows. Then I used MongoDB aggregation pipelines to perform batch analytics. These are batch analytics, meaning the analysis is performed on stored data over time rather than real-time streaming data. In the first example, I grouped titles by the year they were added to Netflix to analyze how the catalog grows over time, which demonstrates the velocity. In the second example, I unwind the gens field where each title can have multiple gens and group by gen to find the most common categories, which directly handles variety. These aggregation pipelines allow efficient analysis directly inside the database. Finally, I visualized the result to clearly present insights, such as catalog growth over time, top gens, and the countries producing the most content for Netflix. Here are the key insights from my analysis. As shown in this chart, movies are still the majority, but TV shows are increasing over time, reflecting Netflix's growing focus on original series. This visualization shows major catalog growth after 2017, reflecting international expansion and the new production strategies that is a clear example of velocity. From this plot, we can observe that the top producing countries are the United States, India, and the United Kingdom, highlighting the geographic variety in Netflix content. The results also indicate that MongoDB rankings identify the longest movies by runtime and the longest running TV shows by number of seasons, demonstrating how variety in duration formats can be normalized and analyzed through batch analytics. Finally, among traditional genres, dramas, comedies, and action-related titles are the most common, reflecting broad mainstream interests. Overall, Netflix catalog is expanding rapidly, diversifying globally and moving toward serialized and international content. MongoDB proved to be an effective choice for handling variety and supporting velocity in flexible, evolving metadata. In conclusion, this project shows how big data concepts appear in Netflix dataset. Variety affects how we model and store the data. Veracity requires cleaning before analysis, and velocity shows how fast Netflix expands its catalog. By combining Python and MongoDB, I implemented a full end-to-end pipeline to clean, store, analyze, and visualize the data and extract meaningful insights. Thank you for listening. I'm happy to answer any questions. Thank you. Bye.